All right, ladies and gentlemen, I'd like to welcome you to this note on scalar and vector quantities. What we're looking at is two different types of measurements that we can be making. And basically the big difference is direction, so we'll see those in a bit. So the first thing is we have these scalar quantities. Now scalar quantities are ones that do not have a direction, and they can simply be described using a number and some kind of unit. So examples of scalar quantities would be things like distance. So you might have a distance of 100 kilometers. So you got your number and you've got your unit. Maybe you have a speed. The speed could be 50 kilometers per hour. It could also be time, for example. You might have a time of 50 seconds. So all of these are measurements. On all these measurements have no direction. They're simply described using a number and a unit. Now what makes vector quantities different is they have a direction. That's the significant difference. They still have a number associated with the measurement, and they also have some kind of unit. And examples might be something like position, and position is kind of like distance, but with direction. So you might have a position of 100 kilometers west. And you notice that I put a direction in here, and the direction is in within square brackets. I could also have something called velocity. Velocity is like speed. The only difference is velocity has direction associated with it. So I could have a velocity of 50 kilometers an hour, and maybe this time we might be going north. So again, we're using square brackets, using n to indicate north. So direction, as I said, for vectors is indicated inside square brackets. Something else that you probably noticed was that when you look at the symbols for these vector quantities, there's a little arrow on top. And this arrow tells you that these quantities have a direction, that they're vector quantities. You must have a direction. Now the arrow doesn't point in the direction that we're going, but it indicates that you must have a direction associated with it. So you've got a little arrow on top of the formula symbol. So here, west, 100 kilometers west, just have a little arrow on top of the D, and that tells me it's position and it's not a distance as we had earlier. All right, so let's define a couple of things. So, everyday measurements, when you look at the distance between objects, you're just looking at how far an object is and how far it's actually traveled. So it's the actual path. And you don't care about direction, but direction really does not matter. Position's a little bit different. In position, we look at the distance and the direction of an object from a reference point. So where is the object? So in other words, where is it in relation to this reference point? So where are you, basically, is what we're saying with regards to position. And a great example would be, say, someone asks you where your home is. Where is your home in relation to the school? And someone might say 5 kilometers. Well, that 5 kilometers is meaningless because which way is it? Is it north, south, east, west? Means nothing. But if you just say that you're located, your position is 5 kilometers west of home, you'd have an idea where you are. So again, that's the big difference between the two. Okay, so let's look at an example here. So what I have here is a little, I guess, number line. And this number line really represents distances of these different locations from a reference point. In this case, the reference point is the bus stop. You always know the reference point because the reference point is always at 0. The other thing we have here, we have to indicate where we are. So if I'm on this side of the reference point, the right side, I'm going to be east. And if I'm on the left side of the reference point, I'm going towards the west. We've got to be careful though, because we want to make sure that we can keep track of things. So I'm going to put a little positive sign here. And this positive sign is going to tell me that east is going to be positive on this side. And anything on the other side of the reference point will be negative. So in other words, west is going to be negative. You see it's going to be important in a little bit. So the first thing to make note of here, again, is the reference point. It's always key to recognize that. So the reference point is the bus stop. And what we're going to do is we're going to write down the location of these different places in reference to the bus stop. So for example, where's the mall? We look at the mall, and you notice the mall is 5 kilometers west of the bus stop. So I can write down my position. So the symbol D with the arrow on top is 5 kilometers west. Another way of writing this, we can also say that it is -5. -5 kilometers east. Now, it might seem a little confusing, but basically what we're saying here is that we're 5 kilometers west. The negative really means opposite. So when you have negative here, the direction is opposite to what's indicated in the bracket. So if we have east here, this negative means this east is really west. So these are equivalent to each other. So in other words, a negative sign in a vector indicates opposite direction. So opposite direction of square brackets. Let's look at another example here. So let's take an example of home. So here, home, we can say is 2 kilometers west of the reference point, the bus stop, or we could have said it's -2 kilometers east. How about the school? Where's the school located? Well, the position of the school is 2 kilometers east. And another way of saying that is -2 kilometers west. Remember, these two are exactly the same. There's no difference between them. So before we go on, it's going to go back up a little bit and look at this example here where I indicated that my position is 14 kilometers east from home in this particular example. Well, a way we can write this down is to use the letter D symbol, arrow on top. That means position. So this is your position. And my position is 14 kilometers east in this previous example. So just want to review this formula symbol here. Now we've got something else. It's called displacement. Now what displacement is our change in position. So change in position, let's look at the symbol for position. Our symbol for position was D with the arrow on top. And in math, change, we use the symbol delta, a little triangle symbol. So this represents change. This part represents position. So a change in position, we call that displacement. So how did your position change, in other words? And usually we look at where we end up minus where we started. So my final position minus my initial position gives me my overall change. So let's take a look at this example here. So here I've got a teacher. The teacher is going to be starting over here. This is my start. And the teacher is walking 4 kilometers east, 2 kilometers south, 4 kilometers west, and 2 kilometers north. So basically they end up at the same spot. So the end and start point are the same. This example is really good to illustrate the difference between distance and your displacement. Let's take a look at that. So distance, remember, is the total path that we actually traveled. So I'm traveling 4 kilometers, then another 2 for a total of 6, then another 4, 10, and finally another 2 for a total of 12 kilometers. So I actually traveled 12 kilometers during this trip. I don't put down a direction because Distance is a scalar quantity. How about this? What's my displacement or change in position? Well, I started over here. I ended up at the same point. There's no change in position. My start position and position are the same. So here, my position change or displacement is 0. And I'm just going to go over here and put down the symbol for displacement. So just an example to give you an idea what the difference is between distance and displacement. Let's look at a couple of other examples involving these, just to kind of further clarify. So in this situation, I've got this student. She's at the bus stop, and it's at 0. So I know that's going to be my reference point. I've got my school, I've got home, and I've got the mall. So what we want to do now is we want to make note of the positions. We're going to have our initial position and our final position. So when I go from the bus stop to the school, I'm starting over here. So my initial position is 0. I'm right at the reference point. I don't have a direction if I'm at the reference point. I end up at school. This is going to be my second position. Let me just kind of clarify that. So my second position is the school. So my school is located 2 kilometers away. It's 2 kilometers to the east. So we indicate this over here. 2 kilometers to the east. And that's my position. So initial, where I started, final, where I ended up. Now my displacement, remember, is my change in position. And the way I can calculate it is look at where I ended up minus where I started. So in this case, I'm going to have this. I ended up at the school 2 kilometers east, and I started at the bus stop 0 kilometers. And when I do the mathematics here, we'll find that I ended up, my change in position, 2 kilometers east of where I started. So again, that's my change in position. I went from here to here, bus stop to school. All right, let's look at another example. What if I did this though? What if I went from the school to the mall? So here, in this case, the school is going to be my initial position, and the mall is going to be my final position. So the school is located 2 kilometers east, and the mall, it's located over here. It's on the other side. It's located 5 kilometers to the west. Just like before, I want to find out the change in position. So I'm going to find the difference between the two. So I ended up at the mall. This is my D2. And my position of the mall was west. And I started originally at school, D1, and my D1 was 2 kilometers east. So I went from 2 kilometers east all the way over here to 5 kilometers west. Got a little bit of a problem here. I can't add or subtract vectors if they're not exactly the same direction, so you be mindful of that. So we're going to have to change one of these into the other directions. I can change the west into east or east into west. So I'm going to do this. I'm going to change this east into a west. So to do that, what we do, I'll keep this part the same. I'm going to make this west. So to do that, I put a negative in front. So I'm going to be subtracting negative west. And 2 negatives make a positive. So I'm going to have this. 5 kilometers west plus 2 kilometers west. You add them together, you end up with a total of 7 kilometers west. That's my change in position. Let's see if that makes sense. So again, in this case, I started at the school, I walked over here 2 kilometers west, and I walked another 5 kilometers west, giving me a total of 7 kilometers west. So my change in position here to here is 7 kilometers towards the west. So it worked out very nicely. I can also do mall to the home. Let's take a look at this one. Now when I'm walking from the mall home, the mall, if you remember, is located 5 kilometers west. That's its position. The home is located 2 kilometers west. You see here it's 2 kilometers west of the bus stop. Remember, position is always measured from a reference point, the bus stop. And I want to know my change in position. So I'm going to go, okay, D2 minus D1. So my second position minus where I started. So in this case, it's going to be 2 kilometers west minus 5 kilometers west. And I get a value of negative 3 kilometers west. In other words, 3 kilometers to the east. Remember, negative west is really east. So my change in position is 3 kilometers east. Let's make sure it worked out. So when I'm walking from mall to my home, I'm walking this way here, and I'm ending up walking 3 kilometers this way, which happens to be east. It worked out well. So all we're doing is just mathematically showing what's going on in the timeline. Now what if I did this? What if it went from home to school and then back home? Well, I'm going to look at my initial position, and back home is going to be my final position. I don't care about what's happening in between. Just look at the beginning or look at the end. So it's going to be 2 kilometers west. That's where my home is. And I end up back at home, 2 kilometers to the west. And when I look at the change in position, I'll be 2 kilometers west minus 2 kilometers west, which gives me 0. In other words, I didn't really go anywhere according to this. I ended up at the same spot, so I don't have a change in position. So I went from home to school, back home. I ended up at the same spot. I don't have a change in position at the end of the day. So hope you have an idea of what's going on in terms of the difference between position, displacement, your change in position, and distance, your actual path traveled. We'll spend a little bit more time on this in class, but I'd like you to at least jot down these notes so you have an idea of what's going on when we do review this in class the next day. Take care.